foundational stuff that you're going to be living with for the rest of your mathematical lives. All right, you're always going to have to take into account whether or not something is a function. Oh, that's weird. So, anyway, relations and functions are important. All right. So, sorry, I'm just distracted by the phone usage over there. It's kind of crazy. Hey, how are you? Good morning. So anyway, a relation is a set of input and output values represented in ordered pairs. All right. A function has a slight distinction from that relation, where each input has exactly one output. All right. So each input has exactly one output. So a function is a type of relation, but it's a very specific type of relation. All right. So that's what we're going to kind of have to wrap our brains around. Now, the title of the unit is functions. All right. So that means that it's an entire unit dedicated to this one concept. All right. It won't end with a test. It'll end with a performance task. All right. So not all units have to end with tests. All right. That's why I left the seating request thing up there. Well, actually, it was kind of fortuitous. The custodians didn't erase it, so I thought it was probably a good thing because I didn't really get too many requests. Right? So it seems like people are generally interested in or concerned, I would even say, about where they sit in the classroom. But when I give you the opportunity to request seats, I didn't really hear from too many people. Right? I mean, I heard from some people, but not. I basically I thought I'd have to go through a clogged inbox. I'd have so many requests, right? But it was really like two requests, 3 requests per class. It's like, but I thought you wanted to have input on where you sat, so like. I guess it can't be both ways. So I'm leaving it up to the end of the day today because since this unit does end in a performance task, a group performance task, you probably would want to have some input. Remember those presentations that you had to do? You know, like if you have input in your seats, that will translate to your partners for any project in this marking period. All right, so hopefully that kind of puts it in a different context. Maybe you're a little bit more motivated to do something like that. All right, you still don't have to. If you don't care where you sit in the classroom, then I guess I'm not talking to you. All right, but if you do, then get out that Remind app at some point and just send me a quick message. I'd like to sit with this person, that person. You can talk location. I'd like to sit towards the front, towards the middle, towards the back, whatever. Yeah, just anything you can think of, any kind of constraints within the classroom. All right, it helps me put together a reasonable seating chart, and generally everybody's happy, right? For the most part, unless I can't honor your request or won't honor your request. That's another thing. All right, so the example for relationship between eye color and student names. All right, so you can see a few different examples there, but the obvious case, well, if you think about a function would be, it would create what we call a causal relationship, which is a cause and effect relationship. All right, so if something is not cause and effect, it's probably not going to be a function. All right, so if you look at the example here, eye color and student name, does somebody's eye color cause their name to happen? Or if you want to even dial it back, is it a predictor of a person's name? Right? Just by knowing a person's eye color, would you know what their name is? Right? No. Now you could narrow it down, like if you happen to know who all the people are that have blue eyes, if I told you that I'm looking for a person with blue eyes, then you could say, it's got to be one of these 50 people. All right, but it's not limited to just one person. It would have to be precisely one person in order for it to be a function. All right, and so in this case, we're looking at green with Sally, green with Poe. All right, blue with Ava. Oh, actually, I should do this like that. I have the technology. Blue could be Erie, Ava, or, oh, actually, no, that's brown. And then brown could be Ben or Tony. All right, so let me see if I have a brown one.
Oh, press the plus button.
I gotta kind of create it. That's orangey.
Go to the bar at the bottom.
You can make it darker.
Yeah.
That's good enough, right?
Sure.
I mean, it's like an orange video.
There we go. All right. So the example for a function, okay, not okay for a function 5, 1, 5, 4. Okay for a function 5, 2, 4, 2. Right. So you would see here that 5 gives you a 1, but 5 also gives you a 4. Right. So, like for example, in a graph, here's 5, 1. Here's 5, 4. All right. So if data points are vertically organized, then it's not going to form a function. All right. So if the points are vertically organized, it's not going to be a function. All right. All right. In the other case, the data points could not be vertically organized. All right. So 5, 2, 4, 2 doesn't necessarily mean they have to be horizontally organized. They just can't be vertically organized. Data points. So points are not vertically organized. All right, so that's a visual way of making a determination of whether something is a function or not. All right, so you can do that anytime you have data points. The problem is if you have names, that wouldn't necessarily play itself out. Although you could create an axis, a horizontal axis with colors and a vertical axis with the actual names. All right, so we have green, blue, brown, green, blue, and brown. I can do that across the horizontal axis. And we have 1, 2, 3, 4, 5, 6 people: Sally, Erie, Ben, Ava, Tony, and Poe. And I could just start plotting some points. So the green one, or one of the green ones, is Sally. One of the blue ones is Erie. One of the brown ones is Ben. One of the blue ones is Ava. Brown is Tony. And green is Poe. So let me just fix this point. All right, and you can see in this case that points are organized vertically. All right, so if that's the case, that means that this is not a function. All right, if they're organized vertically, then it would not be a function. All right, you can manipulate this so that it could be a function, but conceptually it wouldn't be, because again, common sense wise, we wouldn't expect to be able to know a person's name just by knowing what their eye color is. All right, now you could go the other way around. I mean, you'd have to have a pretty incredible memory, but if you knew a person's name, then it would make sense that you could identify a characteristic about that person, like eye color, right, or hair color. Hair color is probably easier, right, because honestly, I have a problem where I tend not to look at people. Like, I look at people, I glance at them, but I don't absorb any information. So, like, you'll have probably 1,000, I mean, you're in school, so like 1,000 encounters with people on a daily basis. You know, whether or not you actually engage with those people is a different story, but you'll actually, I mean, you'll pass people in the hall, you'll talk to people, you'll be in classrooms with other people, and for me, I just kind of gave up a long time ago. And so, like, I'll encounter people, but I don't absorb a lot of information. So if somebody's giving me a hard time in the library, I'll go to the administration afterwards. I'd be like, yeah, this kid was giving me a hard time in the library. They'd be like, what does he look like? I'd be like, well, it was a he. And they'd be like, all right, what shirt was he wearing? A shirt-like shirt. What color was the shirt? I have no idea. You don't have any idea what color the shirt was? I don't remember. What color hair does he have? No clue. Nope, nothing. Okay, so why'd you come here again? Be like, because somebody was giving me a hard time in the library. They'd be like, yeah, but that's all you got. You didn't really tell us anything. And so for me, not something that I could do, but if there is information available about stuff like eye color, hair color, things like that, imagine that there was like a database available, like not necessarily in school, but in the real world. Like maybe the government keeps track of that database, and that database has things like eye color and hair color, and it's associated with some sort of distinguishable characteristic that a person might have, like a fingerprint. If they had something like that, then maybe they could identify a person if that person had committed a crime. That would be interesting. I should contact people and see if they could conceive of something like that, right? Because everybody's fingerprint is unique, and so it would make sense. I mean, they could even call it fingerprinting. I think I just figured something out. Okay, so I'll just I think that's that's how it'd have to be. You'd have to give a finger sample. So you'd have to chop off a finger.
We'll just come off of it. Go like that. Then you would have to do this.
Yeah. So you'd have to lose a finger, but I think that's pretty much it. Okay. Yeah. So I think you got it figured out.
When you steal somebody else's hand, you sign off.
Oh, use ink. Oh, okay.
It's an ID.
Oh, yeah. All right. So like use like ink and then on paper. So you don't have to cut off somebody's finger. It'll be perfectly fine. All right. Okay. See, I didn't think this through. I'm glad I didn't act on this. Okay. So yeah. It's called fingerprinting, and this is a thing, right? When you start employment, especially for government jobs, teaching is considered one of those. They fingerprint you, and they do what's called a background check, right? So they can use that distinguishable characteristic about you and look up other information about you. I guarantee they weren't looking up my eye color and hair color. They were looking to see if I was a criminal. Right, but these are some things that are function-based that you do in your everyday life. Right, so domain and range. Domain is the listing of all possible X values in a data set, and the range is a set of all possible Y values. So when we state the domain, we're doing it using the same kind of notation we've been working with all year long. Every time we were talking about a solution for X, we were stating the domain of X. Every time we were talking about the solution for a Y, we were stating the range of a function. Right? So here, my domain is a simple set of points. So A, might as well use the correct notation. A belongs to the set. We don't have to do the double squiggly, just a single squiggly is okay. Technically, you want to do both, but it's not necessary. So A with a funky looking E, a curved E, means belongs to the set and then you would write what the set is. So green, blue, and we're only writing the unique values. So green, blue, and brown. All right, so that's the domain. For the range, we're just going to include all the unique quote-unquote Y values for each ordered pair. So X, Y. So Sally, Erie, Ben, Ava, so all of the names. It's still set A though, so we would say A belongs to the set. That is a highlighter. Who's the first person? Sally, Erie, Ben. Ava, Tony, and Poe. All right, so we already talked about this. This example is not a function. And we have to state why.
Points are organized vertically.
Points are organized vertically, so that's a graphical way. All right, so points are organized vertically. Now, in terms of just the concept behind it.
Multiple inputs belong to multiple outputs.
Multiple inputs correspond to the same output. Very good. I mean, I don't know how many of you are going to be interested in going down the computer science route. I would imagine probably more these days than in past years, just because, you know, the nature of the world. But the logic behind computer programming is based off of the input-output relationship, right? Because when you write a program, you're telling the computer to perform certain tasks. If you don't have a one-to-one relationship, then the computer does not know what task to perform. So if I mean, a simple program could be something along the lines of, if this, then that. So if this is a condition, then perform this task. All right. So, you know, I mean, there are some actual, I mean, some legit ways to do that in the real world. I don't know if you know the app called Ifttt. It's if this, then that. And so it's a pretty cool app that it runs just certain conditions. And one of the conditions, for example, would be if the temperature is below this number, remote start my car. Right? So you can actually create a condition, and then a task, as long as you have the technology to perform that task. Like, for example, my car, I didn't pay for the Honda Link app, so I can't remote start my car from my phone. But if I did, then I could run that routine, and it would start my car. Now, if I tell it, if the temperature is below this, do these three things, it might get confused. Right? It won't necessarily know which one to do. All right? So you need to be specific, but you also need to make sure that there are no conflicts in your conditional statement. All right. So what we try to do is limit it in the real world to just one output for a single input. All right. So now, if it's another, another possibility could be the confused logic. If the temperature is less than 30 degrees and greater than 50 degrees. You'd be like, well, that's a contradiction. It can't be both. So the whole system breaks down. Logically, it doesn't play out. All right. So, but all of that is based off of the concept of a function. All right. So I have, you're all familiar with the Waze app, I would imagine. I don't know how often you use it, but I always put the Waze app on in the car for the alerts, not necessarily for directions. So I don't typically speed, or at least not outrageously, but I do like to know if there's a cop around the corner, So what I did was I set up a routine on the Ifttt where if I leave a certain region, I define 2 regions, work and home. If I leave, I think it's half a mile around work and half a mile around home. If I leave those 2 spaces, it automatically starts Waze in my car, so that if I forget, it'll do it for me, right? So there were some times where I forgot that I enabled that routine, and I got into the car and I'm driving down 684 and I'm like, I don't remember turning Waze on. Oh wait, yeah, that's because Ifttt did that. So like little things like that, it's all logic based though. And so that's what we're learning about now. We're learning the pencil paper way of handling that. But at the end of this unit, you could conceivably design a routine for yourself using an app like that, all right, as long as you're paying attention. All right? The vertical line test can be used to determine if a graph represents a function. All right? If a vertical line intersects a graph more than once, then the graph is not a function. All right? So it's very straightforward because all you have to do is draw vertical lines in your graph anywhere that, and sometimes it's a mental step, anywhere that one can draw a vertical line, you draw a vertical line and see if it crosses more than once. Now, I have, assuming this works, the ability to, I don't have to draw a vertical line. What I can do is I can make a dynamic line and then just drag it across. All right, so I would ask myself, does it cross this parabola more than once here? No. How about here? Here? Well, basically, stop me at any point where it does. Okay, I'll just move the graph. Did it ever cross more than once? No. All right. So then this one would be a function. So we move on to the second one. At this location, does it intersect more than once?
No.
No, but what about here?
Yes.
Yeah, so this one is not a function. All right, what about this one? So far, so good, right? What about at this location? No, right? Now, if that top one was a closed circle, then it would not be a function. All right, but because it's an open circle, and by the way, that's why we learn about open and closed circles, so that we can create functions. It seems like everywhere that I can place this line, it seems like it would be a function. So we have function, not a function, and function. So F, and F, and F. All right, so everything else after this is practice. So you have the class time to do that.